This question on the math SAT looks hard, but is actually really easy. The function g is defined by g of x equals x times x minus 2 times x plus 6 squared. The value of g of 7 minus w is 0, where w is a constant. What is the sum of all possible values of w? So what we're going to do first is realize that we're looking for where this argument nets to g of x equaling 0. So what we're going to do first is just plug in 0 for g of x, giving us x times x minus 2 times x plus 6 squared. So what we can see here is that we can use the zero product property, which means that we just need to set each of these factors equal to 0 to find the zeros of this function. So doing that is going to give us x equals 0, x equals 2, and then x equals negative 6 as the last zero, because we just set each of these equal to 0 and solve. So these are our zeros, right? So from here, we need to find out what values of g of 7 minus w is going to give us each of these values. So we're going to have g of 0, g of 2, and then g of negative 6. And all of these equal 0. Right, so we're going to set 7 minus w equal to each of these arguments to find all the possible values of w. So 7 minus w equals 0, first is the first argument, is going to give us negative w equals negative 7, and then multiplying both sides by negative 1 gives us w equals 7. That's the first solution. And then for g of 2, we're going to have 7 minus w equals 2, going to give us negative w equals negative 5, and then w equals 5. And then for the last one, negative 6, we're going to have 7 minus w equals negative 6, so negative w equals negative 13. Multiplying both sides by negative 1, we have w equals 13. And then if we add up 7 plus 5 plus 13, we're going to get the sum of all possible values of w to equal 25 as the final correct answer to this question.